Yeah, it's a pleasure to be here. Thank you for the warm welcome. And today we talk about MVC Evolved and how we can build JavaScript applications based on CQRS, domain-driven design, and event sourcing. And I have a question. How many of you have actually worked with CQRS before? Maybe raising a hand or... Okay, event sourcing, anyone?
What is this?
It's a command query responsibility segregation, and that's basically the same as CQRS, so command query separation, which is a pattern which just says you should separate commands from queries. But let's get into that later, in deep. And if you have any questions while I'm talking, feel free. Maybe not too much, but if something's really unclear for you, just jump into it. So early in the 1970s, in the Smalltalk world, Trygve Renskaug came up with the idea of model view controller. We are all aware of model view controller, right? How many did actually something with MVC? Yeah, that looks much better. So the central concept of MVC is to encapsulate the business domain into the model and separate infrastructure and UI concerns into different parts of the system named view and controller. Today you typically connect your MVC models via ORM, object relational mapping, to a relational database and handle access from your view to the controller using CRUD. So the controller handles the model step and we access from the view the controller using CRUD. A famous example for this is Ruby on Rails. We all know Ruby on Rails and its active records pattern. But it's true for the Node.js world too. So there's Backbone.js or Sales.js or meanwhile the mean stack. We all know this is it's quite popular. So when we talk about MVC in the web world today, we implicitly talk about ORM and CRUD too. So let's take as an example our domain, which is a school, and inside the school we have students and courses. And that's basically our business domain. And students should be able to join courses, right? And leave a course. Yeah, that's basically what's standing there. And we start, in the ORM world, we basically start with defining schemas. In this example, we use Mongoose on Node.js. And we have a student schema and a course schema. The next thing we want to do is that students have the ability to join courses, actually. So we have to somehow define the relation between the course and the student. And many students can be part of many courses, and many courses can have many students. So we have several options to actually implement this relation. We could, for example, but how do you actually decide where to put the relation? Anyone? How to decide where to put the relation in schemas? Yeah, it's basically gut feeling. I mean, speaking to a business expert about the relation and how do you define it in a schema is really not that easy, because he will ask, what's the schema? And so, since it's not easy, we just pick one. Student schema seems clear. So we now have in courses students and student schema. And to actually work with this data model, we say from user interface, we need some methods that work with our model, or data structure in this case. And that's where the view and controller comes into play. So that could be user interface. It shouldn't be a user interface because, it's not that pretty. And actually, I painted it while I was in the bus, so it was bumping, and But what we see here is basically what we defined before with our schema, just with a save button added. So we have this course and the name, and we assign new student, and maybe select from the students, and then we hit save. So we store the whole schema into the database. Next would be to define some CRUD rules. So here we just take express, define some roots, and the methods right? So in our case, the update would be triggered and the course update function would be called. And now I have a question for you. Where did the business logic go? We have our school domain and we have students that should enroll in courses and we have written some code, but where is in this code the business logic? Anyone? Yeah, it's nowhere in this code, right? Nowhere in this code stands student joins course. It's just not there. It's in the head of the user, or maybe in the user manual that you provide them. So, is this a bad thing? Yeah, maybe if you're mostly done here, probably not. For rapid prototyping or not complex domains, like simple home pages, or M plus CRUD might be just a fine thing. But there's this guy, the business expert, we all know him. Maybe he looks a little bit different in your environment, but what he wants is reporting or specialized views, right? He comes and says, now let's do some reporting so we can understand our users better. That's a really common thing. And in this case, our business expert wants to know how many students first joined a course, but left it again before it actually started. So how do we implement this with the code we've written before? We could do something like this. We add something that's called students left IDs to our schema, where we then will store the students that leave the course. So you could do it another way. You could define a second schema named reporting and put the students left there, whatever, but just let's stick with this example. And what we now need to do is we change the course update route. And that's basically you get the course ID, you get the whole updated course object. That's a common thing with Backbone, for example. You get the whole object. And then you say, give me the current course out of the database. And now you have to do some comparisons. You have to calculate which students actually left the course. And that could be something like this. So it's just say, calculate students left the course, yeah, magic operation that compares the students property of the both courses, objects, old and new. And there you go. And you save it. Actually, now it gets interesting if you think about multi-threading. Ooh, Node.js and multi-threading, whatever. But if you just imagine we have two threads, or just distributed processes, multiple machines. If two course updates happen at the same time, what will happen?
Last wins.
Sorry?
Last wins.
Last wins, exactly. So you end up with an invalid state in your database because both run at the same time, both calculate their students' left IDs, and eventually you end up with the wrong student left IDs. Yeah, shit, whatever. And actually there's another concept missing here. Who sees it? Right? If a student that already have left the course joins again, he's still in the student left IDs property. So let's fix this. We update the controller route again, and there we go with something that will remove the student from the student's left if he has enrolled again, so joined again. And eventually we end up, hopefully, with the right state. If we now generate this report for our business expert, what would be the result? What would be the result if we now generate the report for our business expert? Anyone? Nothing, because nothing happened yet. We just implemented it, and what should happen is that your users use your interface, and then you eventually end up with some results in your students' left IDs. So it just works from now into the future. Not that cool, but okay. What we've done so far is putting domain logic mostly in our controller, and yeah, a little bit of business logic into the user's head, and we end up with some simple schema. So what's with our model? Actually, we should have a domain model, but there lives just a data definition as of yet. If we keep adding things like that, we eventually end up with a really, really large controller and schema, and our core concept, our core domain will be buried. Eventually, we end up with an anemic domain model. That's another word, yeah, whatever. Martin Fowler wrote a nice article about it, so you can look it up. But basically, that's what we've done so far. And now I want to show you, I need to drink a little bit, and so I left you with 1 minute of video. So, yeah, that was about evolution, right? And the title of the talk is MVC Evolved, so that I thought that might be a fit somehow. And thankfully, the evolution didn't stop in the 1970s with MVC too. So there are plenty of other approaches to design applications. In 2004, so roughly 30 years later, Eric Evans coined the term domain-driven design. The core concept of DDD, or DDD, which is jetzt habe ich mich selbst. The core concept of DDD is that you should concentrate on your domain model without thinking about infrastructure or persistence or user interface concerns. This sounds a bit like the MVC approach, right? But basically, that's where the similarities end. One central concept of DDD is a bounded context. A bounded context encapsulates basically your domain model. So in really large companies, you might have multiple bounded contexts, but these are primarily linguistic things about what I don't talk today, but just stick with one bounded context. If you're a startup and you're just beginning to write code, that's a really good thing to do. Just define one bounded context to have your domain model encapsulated inside of it. And that's what we're doing here. Okay, there's one word I didn't explain yet, that's Eventric. Eventric is just a small micro framework that we wrote in our product. So we are currently building a product and we wanted to apply the patterns that I talked today about. And so we pulled this concept out and named it Eventric, but it's about 600 or 700 lines of code today. So you could basically write it yourself if you grasp the concept. But just let's stick with Eventric so I can show you some code. And our school domain. So we now have, in the beginning we've defined that our core domain is the school. And now we have school actually in our code. That's one thing that's already different from the approach before. The next thing you need is that on the technical side, DDD says that you should get business experts and developers in a room together and talk about the business, not about software. In the process, you should end up with the definition of behavior inside your domain. A really good way to do this is actually called event storming. That's what we see right here. It's about talking what can happen in the domain in terms of events and commands. And if we think back to our school domain, the two behaviors that we can have is student enrolls, student joins in course and student leaves course, right? These are the two behaviors we identified before. And actually you don't have to get to do this event storming inside. You can go outside at the pool side, whatever, and have a little bit of fun. And these behaviors you identify eventually end up in domain events. A domain event will hold your application state from now on. So you actually name them in the past tense, since events describe something that happened in the past. And if you apply them in order, in the order they actually happened, you will eventually end up with your application state. After the event storming session, we get back to our code and define the domain events inside our school. So we have school defined domain events, student joined course, student left course, and student ID and course ID inside. That's our two domain events that will describe the state later and describe what can happen in your domain. Next thing we need is something that's called an aggregate. Aggregate is one of the DDD building blocks. It's partly also known as an actor, and it's basically there to emit your domain events and provide the behavior methods. So what we looked at before was domain events. That's something that happened in the past, but you need something that describes the behavior, like I said here. Let's switch back, whatever. As we said, student join course or student leave course. That's a command, that's a behavior method, and it ends up with this domain events, which says that happened. We are familiar with events. We are using Node, so. So we define the aggregate here. We say at aggregate student and define the first behavior method, which is join course, and if this behavior method gets called, we actually emit the domain event student join course. And here we define the properties. The next thing we need is leave course, and this will emit the domain event to student left course. Now we're back to the really pretty user interfaces I brought. Here I was outside of the bus, so it's not that bumpy anymore, but it should be anyway. But the thing is, you eventually end up with more behavior-centric UIs naturally if you do this kind of style, because you don't think in ORM terms, but you think just in terms of what is the behavior, what are the domain events. So I have enroll or join student in course in a Go button. And if you press this Go button from the UI, we need something that handles this command on our side. So we need something that's called a command handler. The command handler actually takes the command from the user interface and interprets it and eventually calls your aggregate and the behavior method there. So let's define one. We have a command handler and say student join course. Then we say repository student, and then we get the student array here, student aggregate, sorry, and say student join course. So that's where the behavior method gets emitted. And this will actually generate this domain event we talked about earlier. The other thing is student left course, same thing, student leave course, whatever. So now to the interesting part. Reporting using projections. So we still need some reporting for our business expert, the guy at the table who sat there and said, give me some nice reports. And if we now need to generate a report, we can do this without touching any of the code written before. We just write a projection. That's how a projection looks. It says, this handles student left course. this in event-rigged, this will happen by convention. So you just say handle and then the name of the domain event. And if any of if this domain event, if this domain event student left course happens, then it will run again against the projection, and you build up this array. So you have this object. Sorry. So you have student lefts with this course and this course ID of true. So that's the same thing that happened before in our controller. Just we write an encapsulated object for it. It's a projection. So there's something interesting about this too, because this will not only work from now on into the future, but into the past too. Every domain event that already happened can be replayed against this projection. So if you now decide to report, generate some report, you can do it from the beginning of your project, and that's really cool. Your business expert will love it. But one thing is missing here. It's the same thing with the controller. Anyone attending knows? Right. The student left the course, but what if he joins again? You need to handle that, right? So we need to handle the student joined and then delete this course ID out of here again. You should actually make sure that this object is in the correct format, so you don't end up with errors here. But that's basically it. The concepts used here are well known for a longer period of time already, but got recently coined as CQRS and EventSourcing. The CQRS part, to get to this question, is what we saw here is that the read side is separated from the write side. So on the write side, you have your command handlers, which get from the repository aggregate and call a method. That's your write side. And on the read side, you have your projections. So these are completely separated concerns. And you can have a really thin read layer on top of your projections. So you can just get the state out of the projection, or you can write your state of the projection inside a relational database, for example, because relational databases are good for queries or stuff like that. So that CQRS and event sourcing is basically that you store your domain events into a store and be able to replay them. As always, you should keep in mind that there's no silver bullet in software development, right? So make sure that you apply these software design patterns and architecture patterns only where it makes sense. If you're faced with small to medium business value or small to medium amount of development needed, you should consider to just consider to just using or buying a third-party tool, or fast prototyping, whatever. But if you probably will have a large amount of business value and a large amount of development needed for a complex domain, you maybe want to give the DDD approach a try. And actually another thing is cool about this, the underlying concepts work well on a large scale for big companies already for many years. So if you think about banks, so if you log into your Girokonto, whatever, then the amount you get shown is not something that's stored in a relational database, but it's something that is calculated from all your transactions that happen in your account. That's basically event sourcing. And yeah, databases work the same way too. So you have, for example, whatever Oracle will have basically event store to build up your relational database state. Trading, gambling platforms, whatever. And besides that, it's really a lot of fun to keep your domain model crisp and expressive with behavior. And so I will do some live coding now. I hope this will work well because I didn't train it, and it won't take that long, so we're done in about 10 minutes or something. But I just wanted to show you that this can actually work. It's not something that I've made up. So we should now have something. Yeah, there we go. Yeah, we know gulp, so we just start gulp. that looks good. What we need to is Chromium. Which one to take? I don't care. So we now have something running here. So you notice to do MVC. Funny thing, right? I actually take to do MVC to make an example for MVC evolved. That's a bit creepy, but whatever. You can type in. So I want to hold a cool presentation at MNUG. You can make this or rule the web. Yeah, I've done this. Remove this. Clear all completed. Write another one. So awesome. Let's build a pony farm. And what happened now is that we hopefully ended up with some domain events. So I don't know if you guys can see this, but yeah, whatever. I did. Okay, this actually works completely event sourced. So if I reload, it's replayed using a pre-projection and shown here. So, but it's now local storage. What we actually need is we want to connect it to a database because this. Here, everything happened inside of the browser. So I stored it into the local storage, and I'm sure can somehow access the local storage here. Anyone knows it?
Resources.
So resources, okay. And then
local storage.
That's so easy. Okay. And here, can I somehow are they in? Okay, yeah. So that's not the best format to see it actually, but okay. So but. We can take this to another level. So just let's do this. Show sidebar, inventory source, and then maybe here in the client. So what we did here is activated the local storage, but we now, I have here store local storage activated, but now I activate remote store client. So now it gets fancy because Eventric runs totally in the browser, but on Node 2. So let's make sure that this, let's print this list. This makes sense. Let's clear the cache because I didn't figure out how to make this thing actually reload. So now we need to, I have some, that's good. Okay, here we are. So I have received remote finds. So actually what the source code does in the to-do MVC is saying store find, and it goes over socket.io and asks the local database. So if I now say, let's build this pony farm, and I go on localhost in one of the coolest things ever, which not run yet, Cengiz app. Thanks. Then we see we have our bounded context name .events as a Mongo collection, and inside there we have our domain events we spoke about. Actually, there are pretty lot of them. I didn't delete the collection, whatever. But you see, we have to do edit. Here's the payload. That's what we defined earlier with the defined domain events. It's the payload, and here's the aggregate identity from which these domain events were emitted. And one funny thing we could now do is, okay, that's, oh, I spoiled this one. So hopefully no one saw it. So let's write a projection, right? Just write one, say module exports. What we now need is to this handle to do edit. And actually that's CoffeeScript. So I hope I hope you guys don't mind, but for me it's actually much cooler than JavaScript. If you can write it. No, something's wrong here. What I'm doing wrong? That's a function. Should compile. Console log the main event. And then we see, what says the clock? We have time, right? Okay, cool. Because what I'm actually doing. I don't know. I wrote this projection, and now I need to restart this one here. Require node, and then that's a pass error. I'm too dumb because the live coding makes me a little bit anxious. What's the actual? This is a function body, so it's CoffeeScript, and I just leave out this, right? Okay, that's too easy. There we go. So, okay, that's the projections replayed against the projection. Okay, now I'm back on the boat. So what happens if you write this projection is that if you start the process, and your bound context gets loaded, it loads the projection and replays all domain events that are in the store against your projection. So let's say we want to know how many to-dos were added in total to our to-do MVC app. What we could do here is just say stats is gleich this, then we say stats added 0, and then stats plus plus. So simple. We just make sure that stats exist and stats added, and we just increment edit. Sorry? What? Okay. And we could console log just to see what it prints, what its current status. And if I restarted it again, then we see edit 11. So we now have this really simple report. And if you think about your about the to-do MVC application and the typical ORM CRUD approach, if you do a delete, it's gone. Maybe that's from a privacy perspective a good thing, but for our reporting, it's not that cool. So we can actually handle to do removed domain event. Then we say, since this is the first thing that happens, we don't have to do this again, and can just say stats removed, that's removed plus plus, and then restart this thing here. There we go. So now we have a report that says added 11 and removed 8. And to make it complete, we just say handle to do completed domain event. Yeah, whatever. Copy and paste. Yoo! That's good for so many things. Okay, let's do this in the cool way. So and there we go. That's our report. And we could go there. We could go even further. We could, for example, say, now we want to know a history for one to-do item. So you can see how it changed, how its description was changed, or how its complete status was changed, or whatever. And yeah, there's so much to show. Sorry? So much books, so little time. That's from Frank Sinatra, I think. No, yeah. One thing what you can do now is in our to-do MVC, the front end is actually Angular. So we have here a controller with scope, add to do, complete status, whatever, provider that gives us access to our event-trick application. And here is the event-trick part that run before completely in the browser. Here it runs completely on Node. And now we can do something funny. We can actually go here, zip, and then we say coffee, node. So let's reconnect this one. And then we say do MVC should be here, right? Command. Right. That's a bounded context in EventSourcing has a command and a query side. So you can issue commands to the bounded context and say, for example, name add to do with the params and title. Wow, it actually uses socket.io. And there we go. So it's in the browser. That's how the domain event actually flowed first to the MongoDB, and from there floated over event bus into our browser. And in our browser lives the projection, which updates the state. And that's really nice because you can actually scale your application how you want. It's just distribute your system, and you don't run into these problems I've described earlier. You won't end up in a case where you have clashing updates or something, because events are always stored anyway, so you can't overwrite your state. Yeah, and at this point I want to say that if you have any questions, feel free, and yeah, I wrap up. Thank you.
Do you have some questions? Please.
How do you handle the problem that over time the history grows and grows, and you have to transfer basically all events to the client first to replay it there, and then to generate the current state? And that's not scalable over time, right?
On the read side, you have a lot of possibilities. What you can do is replay your events on the server side on a projection and store the state in a denormalized database. And then from your view, you just query the denormalized state. So what you can have is that in our to-do example, you actually end up with something that's really similar to something that you defined before with the ORM approach. So you really have a denormalized database with to-dos, and each to-do has the ID and its complete status and whatever. And you can just query it. But and so you can approach this difficulty. Yeah. But too many events is basically not possible, because events take really not a big amount of space in your database. So if you actually, the guy that came up with CQRS, Greg Young, has a project called EventStore, and they have really, really high performance. They do 50,000 events a second and have really big companies actually running on this approach, and domain events are not the problem, mostly. Mostly the problem is if you have a classical approach where your read side and your write side is the same. So you have to go from the read side completely through your command side. That's where the bottlenecks are, because you have to load your complete write side to make a query. And that's mostly the problem with performance.
So when there are many to-dos, you think that sending them to the client is not the bottleneck? If it happens that a to-do list for 3 years or something?
In this case, you won't send the complete list of domain events to the browser. You won't do that.
Okay.
That's not something you do.
So
because that would be insane.
So you send a cached, some cached state of the event models?
Yeah, what you can do is if you take for example the EventSourcing framework, you have a query side where you can send from the web interface to the server a query, and this query can go to every database you specify in there. That could be another MongoDB collection where you build up your state with the to-dos inside. And so you have basically the read side as before. So you don't send up the domains to the browser, but have a read side and a denormalized database for read. And yeah.
Okay.
Right.
Now I get why it is a bottleneck when you write something, because then you have to replay all of them, right?
If you write them, you don't have bottleneck too. The thing is, often it's often not the writes are the problem in performance terms, but the reads. You have often multiple times more reads than writes. And what actually happens here, if you do a write, you have some logic going on, of course, but that's mostly no problem. There are different approaches to, if you let's say you have an aggregate that has really a lot of domain events going on, you can implement a technique that's called snapshotting, and so prevent bottlenecks that might be accessed there. But if you end with so many domain events in one aggregate, you probably designed it wrong, because that's mostly not the case.
So how do you handle schema changes? Like if you have a bunch of domain events and then you change your schema, wouldn't that be a problem?
Basically, it's you don't have really a schema. Let's say you want to change how a domain event looks, and you change it so that it semantically is completely different from your domain event before. Then it's a new domain event. You have to implement a new domain, because that's another thing. If you have a small change in your domain event, you can do different approaches. You can just add version 2, for example, and have the new domain event flowing to your system. Or you could have a common approach is that you don't update something in domain events. So often it's the most problematic thing with relational databases, for example, are the updates, not the adds, creates or deletes, but it updates. That's where the problems are. And so you can add as many new state variables to your domain event and delete, for example, something, but you don't change one. And so you can just, in newer versions of your application, if something is not in the domain event, you can just ignore it or make a special treatment inside your aggregate or command handler. So there are different approaches to this problem, or to this Herausforderung.
Okay, so you said you wrote a library called EventTrick.
Right.
Did you open source it, or is this just an internal library? Or?
Yeah, it's actually up on GitHub. You can look up on eventtrickjs.org. There's also a getting started guide where you can play with it. And if you have any questions or whatever, you can email me. Email is so outdated. Twitter, dieser Johannes.
Yeah,
Thanks.
thank you very much for your great talk.
Thank you.